Hello and welcome back. In this video we discuss about the concept inviscid flow. To better understand this concept, let us review the concept of viscosity discussed earlier in video 5. Viscosity is a fluid property that is closely related to its flowing behavior. When fluid flows, shear stress develops within the fluid. This shear stress at given surface is proportional to the velocity gradient exists in that plane. The constant of proportionality is called coefficient of dynamic viscosity. The viscous force developed due to the shear stress is important when we analyze fluid motion. In this video, we discuss about an assumption sometimes useful for easier mathematical description of fluid motion. An inviscid flow assumption implies that for a given flow the viscous forces can be neglected. For example, consider steady flow of air around a cylinder. We discussed about streamline patterns that are used for a better representation of such flows. Streamlines are imaginary curves where flow velocity vectors will be tangent to it. In this description, we imagine that the fluid particles slide along these curves. For analyzing motion of a fluid particle, the forces due to pressure, gravity and shear stress are normally considered. For inviscid flow assumption, the viscous forces are neglected. This assumption is valid when the relative magnitudes of pressure and gravity forces are at least an order of magnitude higher than the viscous forces. In practice there is no inviscid fluid. But an inviscid assumption will be useful for easier mathematical description of fluid motion. Thank you for listening.